There are two major ways to classify triangles. You can classify them by their angles, or you can classify them by their sides, or you can do a combination of both. But it's angles or sides is the main. Okay, so if you talk about with angles, acute triangles have all angles less than 90 degrees. And so you get, that's very crooked. Okay, we get like, you know, all the angles are skinny. They're all less than 90 degrees. Obtuse triangles have one angle greater than 90. And it can only be one angle because a triangle is 180 degrees. So if you have one angle that's greater than 90, there can't be another angle that's also greater than 90. That won't work. And these are the triangles that you see that are kind of, you know, really open. So this angle would be greater than 90. If you have an equiangular, all the angles are the same. And if they're all the same, they're 60 degrees, period. So equiangular and acute are kind of the same. Well, sorry, that's not true. They're not the same. Equiangular triangles are acute because they are less than 90, right? But not every acute angle is equiangular. Does that make sense? Okay. And then you have your right triangles, which have one angle is 90 degrees. Exactly. So go ahead and look at these. And acute are less than 90. Equiangular are all 60. Obtuse has one that's greater than 90, and right has one that is exactly 90. So try those really quickly. Okay, so number 1, equiangular. Number 2, obtuse. Number 3, right. Number 4, acute. Number 5, obtuse. And number 6, acute. Okay, classifying triangles by the sides, we're talking about the lengths of the sides. So if you're equilateral, all sides are the same length. If you're scalene, no sides are the same length. Or you can think of it as all sides different. However, it makes more sense to you if you prefer to think of them as all different or none of them the same. And if you're isosceles, exactly 2 sides are the same length. Okay. Now, a special note about equilateral and equiangular. If you're in equilateral triangles, if you're equilateral, then you're equiangular. If you're equiangular, then you're equilateral. They're both, if you're one, you're the other automatically. Equilateral triangles are also equiangular. So most of the time when we're talking about triangles, you'll hear equilateral more than you'll ever hear equiangular because equilateral is easier to say. I mean, it just is equiangular, equilateral. I mean, if you think about it, it's just easier. It's not so many vowels all running together. So they're the same. And aside from the equilateral, you can mix up the other characteristics. And so you can talk about sides and angles together. For example, you could have a right isosceles triangle. So that would be a triangle with a right angle and two sides the same length. Or you could have an acute isosceles or an obtuse isosceles, or a right or an obtuse or an acute scaling. The only thing you can't mix are the equilateral equiangular, because there's no such thing as an equiangular scaling, because if you have all the same length angles or same measure angles, you have all the same length sides. So those two can't mix. Everybody else can kind of mix around, but equilateral and equiangular are always stuck together. Does that make sense? Okay. This is kind of similar to stuff we've had to do before with like midpoints and whatnot. We have isosceles, so two sides are the same, and the two sides that are the same are AB and BC. So I have AB is the same as BC. And since they're the same, that means I can set them equal to each other. And solve it. So subtract 2x from both sides. So I get 2x minus 3 equals 5. Add 3 to both sides. And I get 2x equals 8. Divide by 2, and x is 4. But we had up here, it said to find x and the length of each side. So I need to find the lengths of each side as well. So to do that, I'm going to take that 4 and plug it in. 4 times 4 minus 3. So I have 16 minus 3 is 13. If this one's 13, what's this one? They were equal, right? So this one will also be 13. And then x plus 2 is going to be 4 plus 2, so that's 6. On this problem, it says that it's equilateral, so that means all three of these sides are the same. So you can pick any two. So would you like 3x, 5x, 4x? Which two would you like, 3 and 4, or 4 and 5, or 3 and 5? No opinion? Alright, well I'm going to use 3 and 4 then, because they're smaller. Okay, subtract 3x from both sides. And I get x plus 1 is equal to 10. That was a plus 10. Subtract 1 from both sides. X equals 9. And then I plug that in, but I don't have to plug it into all of these because it's equilateral, right? So I only have to do one. So if I go to, say, this one, and I do 3 times 9 plus 10, that's 27. Sorry, 37. Because 27 plus 10. Then this one's also 37, and so is that one. Why don't you guys try these? It's the same basic exact idea, but I just want you to try them and make sure you got them down. Okay, so we end up with that both of these sides are 20, and that side's 5, and then all three sides on here are 24. Good. So if we look at number 8, I'm going to draw this triangle here. Okay, I did that freehand, of course. You can put the letters anywhere. I mean, on the corners, but they can go in any corner. That doesn't matter. This is number 8. Yeah, this is number 8, sorry. Okay, so then how it says FG is x plus 5. So I'm going to label that x plus 5. GH is 3x minus 9. And FH is 2x minus 2. So the letter corners don't matter, but you want to make sure that you label the sides properly. And then it's equilateral, so all three sides are the same length. And then you solve this exactly the same way as we just did those 11 through 14. And then with number 9, you have an isosceles triangle. Why is that still green? Fixed it. Okay. And you've got LMN, and again, it doesn't matter, just so that you label them. LM and LN are the same length, so those need to get labeled as being the same length. LM is 3x minus 2. LN is 2x plus 1. And MN is 5x minus 2. Okay, so that's how you set those up. Okay, I'm going to do number 10 all the way through so you'll know how to do number 11 and 12. Okay, you're given the corners. We're going to need the distance formula on this one. Okay, so I'm going to, again, freehand draw a perfect triangle. And I'm just going to go ahead and do that. And I'm going to put the coordinates, even though they're not necessarily in the right place, it doesn't matter. I'm just doing this so I can keep track. Pictures help us to do that, that's all. So if I want to find the distance between K and P, I'm going to call this x1, y1, x2, y2. And plug those in, so I get -3 minus 2 and 2 minus 1. So -5 squared plus 1 squared. So 25 plus 1 is the square root of 26. And I don't need to simplify that because on all of these I'm going to get a square root answer. And if they match, then I know I'm good. So I'm just going to leave it square root of 26. Okay. Oh, and we're trying to find out if they're scalene, isosceles, or equilateral. So we have to find all three sides to determine that. So let's say I decide, that was KP, if I do PL. So I could say for this set, I've got x1, y1, x2, y2. So I can do 2 minus -2 and 1 minus -3. And we like happy people, they're positive. So 2 plus 2 is 4, and 1 plus 3 is 4. So I have 16 plus 16. So that's the square root of 32. So that's this length right here. So far I'm not, let's see, we have equilateral, isosceles, and scalene. We're not going to be equilateral, right? Because there's no way all three sides are going to be the same now. So we just need to find this last side. So KL. And I can use this x1 and these x2s. So -3 minus -2 plus 2 minus -3 gives me -3 plus 2, so that's -1 and 5. So I have the square root of 26. That means both of these are the same length. So I'm isosceles.